Okay, so we're gonna first by starting by talking about the similarity in right triangles. The altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So this is only special for right triangles. So if ABC, this big one here, is a right triangle, which it is, and the right angle is angle ACB. CD is the altitude to the hypotenuse. We have this big right triangle ACB. And once we draw in the altitude, we're given two more smaller right triangles as well. And you can see that I drew them all the same way, ADC and CDB. And notice how I kind of flip those around so that they're all oriented the same way. So when I have the altitude, I really have three similar triangles. ABC is similar to ACD, ABC is similar to DBC, and ACD is similar to CBD. So each one is similar to each other because they are all right triangles. So what similarity statements can we write? Oh my goodness. What similarity statement can we write relating the three triangles in this diagram? So the similarity statements that I can make would be that triangle ZXY is similar to triangle ZYW. So I gave you one of those. You pause the video and write the other two, and the answers when you come back. Okay, so off to the right-hand side in blue and red, those are your other two similarity statements from your right triangles once you draw on that altitude. So let's skip on to geometric mean. For any two positive numbers, A and B, the geometric mean of A and B is the positive number x such that the square root of A times B will get you the geometric mean. So what exactly is a geometric mean? I am going to play a YouTube video that kind of explains how the geometric mean is different from the arithmetic mean.
Geometric mean of the numbers 4 and 9, the geometric mean is going to equal 6. So, you know, what's special about the geometric mean? I guess, you know, again, I think an arithmetic mean, it's kind of the middle point, right? And I think, you know, people, you know, you find an arithmetic mean if you want to find, for example, your average grade on 2 tests. So, you know, what does this number 6 represent in relation to 4 and 9? Well, what it has to do with ratios. Okay, so we started with 4 and 9. Those were the numbers that we were finding the geometric mean of, and we found that geometric mean to equal 6. Well, notice if we look at the ratio 4 divided by 6, and then if we look at the ratio 6 divided by 9, well, 4 over 6 reduces to 2/3. Hey, 6 over 9 also reduces to 2/3. So this is kind of what's special about this number, the geometric mean. If you take the ratio of the small number to the geometric mean, and then if you look at the ratio of the geometric mean to the larger number, those ratios or those fractions are going to be the same. Okay, so that's how you can kind of think about the geometric mean. Somehow it's giving equal ratios of those two values. So again, the arithmetic mean is the one that I think most of us are a little bit more used to.
So there's your little blurb on what's special about the geometric mean. So let's do an example. In number 1, what is the geometric mean of 6 and 15? Well, we take the square root of 6 times 15. 6 times 15 is 90. And that is not a perfect square, but if we really wanted to, we could reduce it down to 3 square roots of 10. So that is my geometric mean of 6 and 15. So let's come on down to the geometric mean in right triangle theorem. The length of the altitude to the hypotenuse of our right triangle is the geometric mean of the lengths of the segments of the hypotenuse. Okay, so let's look at this example. So we have my altitude here, which is 4, and we have the 2 lengths that my altitude kind of divided up my hypotenuse into. So once I drew in that altitude, it split up the hypotenuse into a section of 2 and a section of 8. So what we can do here is my altitude should be equal to the square root of the broken up hypotenuse, those 2 numbers being multiplied together. So we have the 2 and the 18, and that's how, or the 8, that's how the altitude split up my hypotenuse. And when I multiply those both together, I get the square root of 16, which is in fact equal to 4, which is my altitude. So there's kind of how that played into it. Let's go over on this side here. And we don't really want to talk about this part. So let's just go down to another example. So remember, my altitude should be equal to the splitting up of the hypotenuse. So it's split into 1, and since this whole length is 4, we know that this little part from here to here is 3. So my altitude should be equal to these 2 numbers being multiplied together. So we have 3 times 1, and the square root of 3 times 1 is the square root of 3. So that is my altitude. The square root of 3. Okay. So this also makes sense if you think about it using ratios. So if I'm looking at this triangle here, the one that has the 3 on it, if I was to draw it, if I just kind of tipped it 90 degrees clockwise, I would get, whoops, not the 3 there. I would have this triangle, and here's my right angle, and it looks like the height would be 3 there, and the altitude is now going to be at the bottom here, which is called the altitude x for now. And I'm comparing that to my smaller triangle, which I'll draw in blue, and he's already oriented the same way as I just drew this other guy, except my length on the bottom here is 1, and the height of the triangle is the altitude, which we said we were going to call x. So if you think about it, let's start by writing 2 ratios. We have the bottom part of the first triangle, the bigger triangle. We said that was going to be x, our altitude, and the bottom part of my smaller triangle is 1. Let's set up a ratio, so we'll set that equal to the heights of both, which we said are 3 and x respectively. So if you cross multiply and solve, you will get x squared equal to 3. And when you square root both, you will get x equal to square root of 3, just like we said up above what it should be, the altitude should be. So even if you do forget that when you draw in an altitude, it splits apart the hypotenuse, you have to multiply those together and take the square root of it in order to get the altitude. Even if you forget that, you can solve for the altitude by using ratios instead. So on the back here, there are 4 practice problems. Go ahead and try those to finish up your homework and come in with questions, comments, or concerns next class, and this back done.